business calc people. Here's a second problem in which we want to find the rate of change of some model that's given and find and interpret it evaluated at some point. We're given this equation, R of P, which stands for millions of dollars of revenue for car seats at price P. So R of P is millions of dollars of revenue, the output, and the input is the price for each car seat. Okay? We aspire to find, for part A, the rate of change model, which is R prime of P. And recall, R prime of P means take the derivative of P with respect to X. Take the derivative of R, dr, with respect to P. Okay? Now, all that means is I do d dp of our function here. 2.426 times 0.989 raised to the p power. All right? Now, before I continue, let's review how to take the derivative of a function of the form f of x is equal to some a raised to the x, where a is just a constant, okay? d dx of this, so f prime of x, which is equal to d dx of a to the x. This is actually equivalent to a to the x times the natural log of a, okay? So the way we do that for a to the x is the d dx, which is the derivative of a to the x, is just a to the x times ln of a. So over here, our a is this number, 0.989, and our x is p. Notice that the derivative will totally ignore this constant. So this constant just comes along for the ride here. And now I do d dp of this 0.989 raised to the p power, okay? So this comes along for the ride, 2.426 times, we just get this whole thing again when we take the derivative, times the natural log of what's on the inside, 0.989. Because in this instance, that is playing the role of A. 0.989 is playing the role of A. Okay? Don't think about it too hard. This is just the rule of how to take the derivative of these forms of functions. That's just how it goes. Do it and you'll get the right answer. Okay? So now, when we put these all together, this is just equal to 2.426 ln of 0.989, nothing your calculators can't handle, times 0.989 raised to the p power. This is the derivative. This is r prime. R prime of p. Okay? This is the rate of change model. So part A is done. What is part B? We're going to evaluate r prime of 155. R prime of 155 is equal to, replace every p here, which is just one of them, with 155. That's it. So this is equal to 2.426 times ln of 0.989 times 0.989 raised to the 155 power. Okay, let's clear up some real estate here. Okay, clearing up some real estate here. All right. All I got to do now is plug this into a calculator. You got calculators at home? Let's race to see who can do it faster, and let's see what your answer compares with my answer. 2.426 times ln 0.989 times 0.989 raised to the 155 power. Okay, I get negative 0.00, what does that say? 4831. Okay, and we want to round to the 100th place. So take a look, 10th, 100th, okay? This is as close as we get, so we're not going to round up. Okay, so this is our answer. It's a negative rate of change. So it says find and interpret what's going on here. Well, it looks like for the price of $155, for a car seat, the rate of millions of dollars of revenue is decreasing by this amount. Okay? By this amount, this is the rate at which the revenue is decreasing in millions of dollars. The revenue is decreasing by this amount in millions of dollars whenever we price the car seat for 155 bucks. Seems like we're overpricing it, and we might want to reconsider how expensive we make these car seats. You know? Let those babies have some cheaper car seats, please. Thank you very much to everybody who give me some requests, and I'll do videos solving your problems for you. Thank you very much.